Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking find an algebraic expression and also put it in sum of product form. Now algebraic expression is they're asking for the what's going to be the final output of this given circuit in terms of C, D, E. Now let's look at this one. Here we have D and E entering the OR gate. So when something enters the OR gate, we have to add. So we have to put D plus E. So this is going to be the final product of this one. And when C enters the NOT gate, that's going to become C NOT. And here we have C, D and E entering the NOT gate. This is going to become E NOT. And D plus E is entering the AND gate, and also C NOT is entering the AND gate. Finally, we are going to get an expression like C NOT times D plus E. Because when something enters the AND gate, it's similar to multiplication. So here we have C, D, E NOT is entering the AND gate. So this is going to become C, D, E NOT. And these two are entering the OR gate. So finally we are going to end up with C, D, E NOT plus C NOT D plus E. Right? Here we have sum of product. Right? This is sum of product, and also we have product of sum. Both of them are in the same thing. But the final question is asking to express this one in terms of sum of product. Now what we have to do is we have to simplify this one. In order to simplify, we just multiply this one, and that's gonna give us C, D, E NOT plus C NOT D plus C NOT E. Okay, so this is going to be the final expression in terms of sum of product. Now this is not the only way to write the final answer. There are many different, you can also express this one in terms of minterm and maxterm. Now let's see how we can do that. So in order to create that one, I have to create the table first. Let's get rid of this diagram. Okay, I'm going to create the truth table for this one. Truth tables, here we have three variables. We have C, D, E. So in truth table, the number of combination depends on the variables. Since we have 3, 2 power 3, that's going to give us 8. So we are going to have 8 different combinations. Now let's go ahead and create the table for that. So first, let's go ahead and create the table. We are going to have 8 different combinations. 1, 2, 3, 4, 8 different combinations. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is our table, and also it's better to illustrate with a diagram. Okay, let's draw the diagram for the given one. C, D, E bar, right? We have, this is in AND gate, so C, D, E bar, and also we have C bar D, C bar D, and then we have okay, let's get rid of this. Then we have C bar E, C bar E. All of them are entering OR gate because we have addition. So all of them are entering OR gate. Okay, let's look at the combination. Here we have 3 different variables, right? So we have C, let's write with a different color. We have C, D and E, and the final product is G. So when we have 3 different variables, we are going to have 8 different combinations because 2 power 3 is equal to 8. So this goes like that. If you want to remember the combination easily, the way to remember is the pattern goes like that. You will have, okay, let's use this color, 0 1 0 1 0 1 0 1 2 4 6 8, right? Then 0 0 1 1 0 0 1 1. then we will get 4 0 4 1. So this is going to be the combination. Now let's see what's going to be the final product. Now this is what we are looking for. We are looking for the truth table for this one. In order to get a 1, one of them has to be 1, because in OR gate, if one of them is 1, the final product will be 1, final results will be 1. It doesn't matter whether this is 0, this is 0. So just one has to be 1. So what we can do is, if we check each term where we can get 1, that's going to result in 1. Okay, so I'm going to check each term. First, let's start with this one. Let's start with this one, C, D, E bar. In order to get 1 right here, what we had to have? We had to have C is equal to 1, D is equal to 1, E bar also equal to 1. But E bar mean E complement. So E has to be 0 in order to get E complement 1, right? So if these 3 are 1, we will get 1, because in AND gate, we had to have 3 of them. Like whatever the term multiplying, all of them has to be 1 in order to get 1. So we had to have C is equal to 1, D is equal to 1. E has to be 0, because here we have E complement. That gives us 1. Now let's look at this one. We have to have 1 1 0. Let's see. Here we have 1 1 0, only one location, right? So this is going to give us 1. We don't have any other location where we have C is equal to 1, D is equal to 1, E is equal to 0. So this is the only location. And in the second one, we had to, in order to get a 1, we had to have C is equal to 0 and D is equal to 1, because this C is equal to C complement. So if C is 0, that's going to become 1. So we had to have C is equal to 0, D is equal to 1. C is equal to 0, D is equal to 1. Let's see. C is equal to 0, D is equal to 1. This is 1. C is equal to 0, D is equal to 0. This is 1. And the next one we had to have is C bar E. So C has to be 0, E has to be 1. C has to be 0. C has to be 0, E has to be 1. This is 1. And that's it. So those are the things that can produce 1. Others are going to be 0. Okay. Now let's look at the location. And also let's illustrate the same thing in this diagram. Okay. Here we have the diagram. So if this is 0, this is 0, this is okay. That's wrong. Let's see the possible situation where we can get 1. That's what we are looking for, right? So this has to be 1. So this has to be 1, this has to be 1, this has to be 0 in order to get a 1. And this has to be, C has to be 0, and D has to be 1 in order to get a 1. And here we have to have C has to be 0, E has to be 1 in order to get a 1. That will result in 1. Okay, that's how we did this one. Now let's look at let's see how we can write the minterm and maxterm. That's why we are looking for the truth table. Now before we do that, we have to know the location. So this one, the first, we start from 0. See, it goes, the location goes like 0 1 2 3 4 5 6 7, because we need this location when we express our terms in terms of minterm and maxterm. Now let's see how we can express this one in terms of this result in terms of minterm and maxterm. Okay, now we have the truth table. We are going to use this truth table to express that. Okay, let's use this color. Minterm and maxterm. Let's look at the minterm first. When we express minterm, we write like this. This is function of G contains C, D, E. And when we write minterm, we put summation sign and small m. The location. When we express minterm is the location where we have ones. We have 1 at location 1, 1. And we have 1 at location 2, 2. We have 1 at location 3, 3. And we have 1 at location 6, 6. So this is going to be the expression for minterm. In other words, we can call minterm as sum of product. Now let's look at the location of maxterm. So when we express maxterm, we put a phi right here and capital M, and we look at the location where we have zeros. In the location 0 we have a 0, 0, and when we have location 4 we have a 0, and location 5 we have a 0, and location 7 we have a 0. So this is called max term. In other words, we can call product of sum. Okay, usually the question are in the question they will give you this one, minterm and maxterm, and they will ask you to derive the expression in terms of sum of product and also product of sum. Now let's see how to do that. Let's get rid of this part right here. Now first let's start with how can we derive a sum of product equation from this one. Okay, so when we want to derive sum of product, we have to choose minterm. That's going to give us a sum of product. And if you want to derive an equation in terms of product of sum, you have to use the max term. Now first let's see how to derive an equation that contains sum of product. Now in order to do that, we have to pick up the location 1, 2, 3, 6 and see what we have right there. In 1 we have 0, 0, 1. So C, D, E we have 0, 0, 1. In 2 we have 0, 1, 0, 0, 1, 0. In the location 3 we have 0, 1, 1, 0, 1, 1. In the location 6 we have 1, 1, 0, 1, 1, 0. Okay, so these are the things we have in these locations. And we want to get a result that's 1. That's our purpose, because in minterm we are looking at the locations where we have the product that's equal to 1. Now in order to get 1, what we have to have, okay, if you put a, like here we are dealing with AND gate, so this one C, D, E. Okay, when you talk about minterm, this is one of the things you have to remember. When you talk about minterm, you have to consider AND gate. So you have to see multiplication of what will give us 1. And when you talk about max term, you have to think about OR gate. When you product when you product something, what will give us 0? So you have to look at in that way. But here since we are dealing with minterm, we have to look at AND gate. So AND gate means what multiplication gives us 1. Here in order to get a 1 in the first one, we had to have C to be bar, because C is 0 right here. So I need the eraser. Let's get that one. Okay, C has to be bar because we have C is equal to 0. So C has to be a bar. C has to be a bar. And D also has to be a bar. And then E has to be remain the same in order to get a 1. So that's the first one. Let's look at the second one. We have 0, 1, 0. So C has to be a bar and D remains the same, and E has to be a bar, or we can say C has to be C naught, E has to be E naught. And then the third one, we have to have C has to be C naught and D E. And the last one, we have to have C D E naught in order to get a result that gives us 1, right? So this is what we derived from this location. That's why these locations are helpful. Now we derived this one. Finally we had to simplify this one in order to get a final sum of product. Now let's see how we can simplify. Here from this one you can see C bar D E. Okay, this one I can write it twice, because when we put an OR gate, in OR gate, if you have A plus A, that's equal to A. So when you have A, you can write it as many as you can write it many times, because the product always gives us A. So what you can do is this one you can repeat it again, because if you repeat this one again, that's going to help you simplify this one easily. Let's see how it's going to help us. So first I'm going to write C bar D bar E, then C bar, I'm bringing one of this here, C bar D E, and then C bar D E bar plus C bar D E plus C D E bar. So I just wrote this one twice. Now you will see how it's going to help us, to simplify. Here you can see, here we can take C bar E common, C bar E common. If we take C bar E common, what's going to happen? We are going to have D complement plus D. Okay, you can say C bar or C naught or C complement. All of them are correct terms. Okay, so D bar plus D, and also here we can take what? We can take C bar D common, C complement D common. If we take that one, what's going to happen is we are going to hit E complement plus E, and we are left with this one is C, right? C D E bar, C D E naught. Okay, so when we have OR gate and we have a complement D and its complement, it's going to be 1, because if one of them is 0, other one is going to be 1, and other one is 0, this one is 0, this is going to be 1, this is going to be, if this is 1, this is going to be 0. So there is at least 1 there. So in OR gate, we just have to have 1 in order to get a 1. So this whole thing is going to result in 1. The same thing happened here. When we have E and its complement, it's definitely going to be 1, because we are going to have at least 1 right there. So these two are simplified right now. So the final answer is going to be C bar E. We can neglect the 1, because if you multiply this one by 1, that's going to be just 1. So C bar E and then C bar D plus C D E bar. Now you can see we derived product of sum. So this one is actually sum of product simplified. Sum of product, because we are summing the products, right? And that's it for this one. Now let's see how we can derive product of sum. Same thing, like same way, but when you think about product of sum or max term, you had to think about OR gate. Before we think about AND gate, and see we put it like this, right? But for this one, you have to look at OR gate. Now let's see how it's gonna work. Okay, now this thing is going to be different. Now we have to look at the location where we have 0. Okay, in the max term, okay, I have to get rid of this one too. Now we are going to talk about how to derive product of sum equation. In the max term, we have the location 0, 4, 5, 6. 0, 4, 5, 6. See, at 0 we have 0, 0, 0. And at 4 we have 1, 0, 0. And at 5 we have 1, 0, 1. And at 7 we have 1, 1, 1. Okay. Now let's go ahead and create the diagram for this one. We are going to have 4 OR gate. Okay, and all of them are connected to an AND gate. So this is for max term. If you talk about min term, this is opposite. All of them are AND gate that is connected to an OR gate. So when you talk about max term, all of them are OR gate connected to an AND gate. Okay, so what we have to see is, in the first one, this is C, D, E. We have to, when we talk about max term, we are talking about getting a 0, right? When we talk about min term, we are talking about getting a 1, right? Since we are talking about max term, we have to see what values gives us 0. In the first one, we already have 0, 0, 0. Will it result in 0? Of course, in OR gate, if all of them are 0, this is going to be 0. So we don't have to change anything. So we just can leave it like that. Finally, we have to get a 0. And here we have 1, 0, 0. We have C, D. So this is C, D, E. C, D, E entering. And 1 means C is 1. 1, 0, 0. Will it result in 0? No. Because in OR gate, all of them has to be 0 in order to get a 0. So this has to be a C bar in order to get a 0, right? So that will result in 0, because if you put a 1, if you take a C not for that, that's going to be 0, 0, C, it's already 0, we can keep it like this. So that's going to result in 0. Now let's look at the third one, C, D, E. So here we have 1, 0, 1. So we cannot keep the C as it is because C is 1. So we have to put C naught in order to get a 0. And also E is 1. We have to put a E naught in order to get a 0. Now all of these three are 0. That's going to result in 0. And the next one is, here we have again C, D, E. Last one is all of them are 1. This is 1, this is 1, this is 1. So we cannot leave all of them like this because we want to get a 0. So in order to turn all of them into 0, we just put not for everything. So C naught, D naught, E naught. That's going to give us a 0. So this is going to be the final expression. First one we got C plus D plus E. And in the second one we have C naught, D, E. C naught plus D plus E. And the third one we have C naught, D, E naught. C naught plus D plus E naught. In the last one all of them are naught. Times C naught, D naught, E naught. Let's write the final answer clearly. Let's get rid of this diagram. Okay, let's get rid of this one. Let's write the final answer clearly again. We have C plus D plus E, and then we have C naught plus D plus E, and then we have C naught plus D plus E naught, and then we have C naught plus D naught plus E naught. Now we can simplify this one furthermore. To do that, we have to remember one thing. We have to remember a rule that says when we have x plus y and x bar plus y, that is equal to y. Let's go ahead and prove that one first. In order to prove that one, I had to FOIL it first. So FOIL, if you FOIL this one, FOIL mean we multiply this one with this one and this one with this one. X times x bar, that's going to result in 0. And x times y, that's going to be xy, and then y times x bar, that's going to be x bar y, and then y times y, that's going to be just y, because when you have a and a, that's going to be result in a, because if it's 0, that's going to be 0, if it's 1, it's going to be 1. So the result depends on a, therefore the final answer is going to be a. The same thing goes to y. And the next thing is we can take the y common, and that's going to be what we are going to get, x plus x bar plus 1. And in OR gate, if we have 1 1, it doesn't matter whatever we have other things, it's always going to result in 1. So this is going to be y times 1. So finally we get 1 y. This is going to help us because we are going to use this one in order to solve this one. Here you can think this one is, you can think this one as x and this one as y, right? This is y and this is x bar, this is y. So finally what we are going to end up with, we are going to end up with y. When we multiply, we are going to end up with y. Y is what? D plus E. So that's going to be the results for these two. And here you can see we can combine. We have to look at the like terms. So this, if I rearrange this one, this is going to be D plus C bar plus E bar, and this one D bar plus C bar plus E bar. Now you can see the pattern. This one we can call it as x, right? This one x bar, and this one is y. When you multiply, what you're going to get, we are going to get y. Y means C bar plus E bar. So this is going to be C bar plus E bar. So this is going to be the product of sum simplified. So that's how we can get sum of product and product of sum when the min term and max terms are given. I hope this helps. Thanks for watching.